Hi everyone, this is Kiranmai from H&S department. Today in this session, we are going to discuss about a Zener diode. Under this topic, we are going to see what is Zener diode, what is Zener effect, how a Zener diode will work, what are the different breakdown mechanisms that we can see in a Zener diode, characteristics of Zener diode, and the applications of Zener diode. First of all, what is a Zener diode? A Zener diode is a special diode which is mainly developed for the working in reverse direction. Why? Because a normal PN junction diode can work very perfectly in a forward direction, where the with the input forward potential, forward current also increases. But when you apply a reverse potential to a normal PN junction diode, at high reverse potentials, the junction is getting damaged and the device is not working perfectly in reverse conditions. To avoid or to uh, avoid those disadvantages in reverse conditions by a PN junction diode, a new diode has been developed by a scientist called Zener, which is known as Zener diode, which can work perfectly in reverse conditions at high reverse voltages also. Hence, a Zener diode is a silicon semiconductor device that permits current to flow either in a forward direction or in a reverse direction. And this diode consists of special heavily doped PN junction designed to conduct in the reverse direction when a certain specified voltage is reached. So to make it perfect to work in reverse bias condition, while constructing a Zener diode, it is heavily doped rather than a normal PN junction diode. What is Zener effect? Zener effect is nothing but when the voltage across the terminals of a Zener diode is reversed, the potential reaches to Zener voltage known as new voltage. The junction breaks down and the current flows in the reverse direction. This effect is known as Zener effect. Coming to the working of a Zener diode, the Zener diode operates just like a normal PN junction diode when it is forward biased. However, a small leakage current flows through the diode when when it is connected in reverse biased mode. As the reverse voltage increases to the predetermined breakdown voltage, current starts flowing through the diode and the current increases to a maximum which is determined by the series resistor, after which it stabilizes and remains constant over a wide range of applied voltages. There are two different types of breakdown mechanisms that happen in a Zener diode. Those are avalanche breakdown and Zener breakdown. Avalanche breakdown, which is nothing but as same as an breakdown voltage in a normal PN junction diode. Avalanche breakdown occurs both in normal diode and also in a Zener diode at very high reverse voltages. When a high reverse voltage is applied to a PN junction diode, free electrons gain sufficient energy and accelerate themselves with high velocities. These free electrons moving with high velocity collide with other atoms and knock off more and more electrons from the atoms. Due to this continuous collision, large number of free electrons will be produced. As a result, electric current in the diode rapidly increases. This sudden increase in current may permanently destroys the normal diode. However, in Zener diode, it is designed to operate under avalanche breakdown and can sustain sudden spike of current. So avalanche breakdown occurs in Zener diode with Zener voltage about 6 volts. Whereas Zener breakdown, when the applied reverse bias voltage reaches closer to the Zener voltage, the electric field in the depletion region gets strong enough to pull electrons from their valency bands. The valency electrons that gain sufficient energy from the strong electric field of depletion region break free from the parent atom. At the Zener breakdown region, a small increase in voltage results in rapid increase of electric current. So by this Zener breakdown region, when the diode reaches to this Zener breakdown region, even for small increase of voltage, there will be rapid increase in current, which makes the diode to get damaged. Whereas in avalanche breakdown, it will get stabilized and produces current. The circuit symbol for a Zener diode is as similar as an PN junction diode, except there is a small change at the cathodic region. That is, instead of putting a straight line, here a jet symbol has been made. Coming to the VI characteristics of Zener diode, the VI characteristics of Zener diode can be divided into two parts. One is forward characteristics and another one is reverse characteristics. The first quadrant of the graph represents the forward characteristics of Zener diode, which is as similar as a PN junction diode, which means that as you give forward potential to the Zener diode, forward up to certain potential called as knee potential, there is no current in the circuit. Even before, even after that also, if the input potential is increased with respect to the input, output also increases continuously, which is as similar as an PN junction diode. Whereas in reverse characteristics of Zener diode, when a reverse voltage is applied to it, a small reverse current flows through the diode due to minority charge carriers of the material. Holes on the p side, electrons on the p side and holes on the n side. This current is due to thermally generated minority carriers. As the reverse voltage increases, certain value of reverse voltage and reverse current increases drastically and sharply due to breakdown of due to knocking of electrons from the material. This is an indication that breakdown has been occurred. We call this region as voltage breakdown voltage, or Zener voltage, or VZ denotes. On the screen, you can observe that there are two different breakdown mechanisms. One is Zener breakdown, another one is avalanche breakdown. Coming to the applications of Zener diode can be utilized as a voltage regulator, as a over voltage protector and clipping circuits. So coming to the voltage regulator, Zener diode is used as a shunt voltage regulator for regulating voltage across the small loads. The Zener diode is connected parallel to the load to make it reverse bias, and once the Zener diode exceeds the knee voltage, the voltage across the load will become constant, because in the region of in the region of knee voltage, the even the increase in voltage becomes output becomes constant, hence voltage across the load will become constant. So the breakdown voltage of Zener diode will be constant for a wide range of currents. Even the current is increasing, that Zener voltage will be constant. The Zener diode in over voltage protection. The application of Zener diode in over voltage protection. When the input voltage is higher than the Zener breakdown voltage, the voltage across the resistor drops, resulting in a short circuit. This can be avoided by using Zener diode. For clipping circuits, it is used for modifying the AC waveform clipping circuits by limiting the parts of either one or both of the half cycles of AC waveform. These are the three different important applications for Zener diode, where it can be used as a regulator, voltage protector, and clipping circuit. Thank you.